forgot who my audience was. Sorry about that. You're so youthful in your enthusiasm. I forgot about the probability of the challenge in the. Anyway, so I've been here a few times before, and I have a lot that I want to share. And anytime anybody has a question, please jump out and ask. One of the things that was, no questions. Okay, there's a lot of new rules since I was here last. Was it? I'm gonna guess maybe. Okay. You're stuck with me for 40 minutes. So this talk, I need to credit the TEDx Salem group. I have the great privilege of being a professor at Willamette. It's my 16th year. And that puts me in cycle for, I just finished my second year-long sabbatical in that period of time. Going into that sabbatical, I started working at Cornell the summer of 2015 and then was again there recently. It was a dream of mine. I have the great, I've had lots of opportunities and I couldn't decide to go to University of Colorado Boulder for my PhD or Cornell. My new wife was going to University of Colorado Boulder, so I thought I'd go there. But I always wanted to go to Cornell, and so I stayed in it long enough that I got to do that. The TEDx Salem folks asked me to give a talk about whatever I wanted, and they wanted me to talk about crows because that was what I did on my last sabbatical. And crows are really cool and really popular, and we're not going to talk about them today. I'm at a midlife point where I'm sort of pivoting, trying to figure out why does my life matter? Why do these birds that I care about so much matter? And then what are ways to convey that to audiences that aren't quite as flocked up as I am? And the opportunity to give a 12-minute TED Talk really was exciting and also a lot of pressure. And so I'm just going to, you can watch the TED Talk. It was in the link. I just want to have the dramatic music to start this talk 'cause it's so cool. Okay, let's see if we can get that to play. And this is another one of these great things in our community. Let's see, is it going to play? Go, okay. And we'll just get my first line, and then that'll be sort of. Oh. I'll just tell you. The lead line was, every bird has a story. Every bird has a story. And so what I'm going to do today, I'm going to take the 12-minute talk, and since you're the ICL, I'm going to turn it into a 40-minute talk. And I have to say, I have like a 9-hour talk. And what this talk is going to be about is every bird has a story. Every bird matters. And then I'm going to go and take the individual lives of particular birds and turn those into kind of hero journeys. Why these particular birds tell us about a lot of different things. Someone's going to tell about me and my childhood. Someone's going to talk about society. Someone's going to talk about climate change. Someone's going to talk about mysteries that we don't have the answers to. So this particular bird is a Caspian tern, and this is the bird that has I've made more discoveries in and probably made more contributions to new human knowledge than any other space. Caspian terns are not as popular as crows, so people don't care about it as much, but I'm going to try to make you care. This particular bird is my Pfeifferstorch. And some of you, I gave a talk a long time ago about bird migration. Does anybody remember what Pfeifferstorch is? Just raise your hand. I'll tell you what the answer is. Okay, nobody remembers. This is a huge story, Pfeifferstorch. It's a funny word. It's German. We'll get to that in a minute here. Let's go forward. Okay, this is kind of my unicorn bird. The title was Bird in the Hand. Here is a picture of me with the Field Guide to Western Birds that my step-grandmother gave me, and actually gave my family in 1974. I'm the oldest sibling, so I decided it was mine. And there's the inscription, and you can see, if you look at the pictures of my childhood, I'm the first in my family to go to college. I didn't know you could be a professor or a bird watcher for a job. I thought I'd be a veterinarian or maybe a medical doctor. You're going to see lots of pictures, just like David at 8. We'll finish this talk with me holding a bird in the hand. There's lots of ways in which the parable, bird in the hand, conventionally means, be appreciative for what you have. Don't throw it away to try to get more. There's ways in which a bird in the hand today can really tell us a lot about the value of a particular habitat or environment, and that caring for that bird and thinking about that could be really valuable. Okay, we're gonna start with a hero story of a bird that some of you may know, Ron Jakes. He's a surgeon in town, good friend of mine, and I get a text at 5 in the morning. Call me ASP. What's up? Ron doesn't usually text me. I was attacked by a bat running this AM, stole my cap and came after me. I'm like, that's weird. That's not cool. And then what I knew right away was it wasn't a bat. I talked to him and he thought it was this huge bat and attacked, and I knew it was a barred owl or a gray horned owl. And you all know that story as gray horned owl attacks jogger. Sam, this is the first story. In the text, though, my childhood and professional bird knowledge, I knew that it was going to be either a gray horned or a barred owl. And this story, I want to tell this because it's a signature of Salem and how an individual bird provoked the whole community. We had a little bit of fear, and one of the roles I played was have a lot of fun too. So when the reporters called, I was like, "Don't be afraid. This is good. We have a habitat that's robust enough. Bush bark is vigorous, so we have predators. This is good." And we had this, turned into this national media story with Rachel Maddow having a new sign. Now those are in the park. There's all these beers that are named after the owl. And what did we name this owl? We named him Al Capone. We had a naming contest. And this was one of the things that when I did the TED Talk, they said, okay, if you're not going to talk about crows, you have to talk about the owl somehow. So this is an example of an individual bird that its behavior really made us all think. And then some students and I went and found the bird. One of the things that's challenging about this bird was it wasn't marked. So that first turn that I showed you, I didn't call attention to it to see if anybody noticed, but it was marked. It had little bracelets on its leg. Now, this is one of the things that that is a bird I call a field-readable bird or a banded bird. Al Capone's not marked. So whenever new people are attacked by owls, we can't really credit Al Capone. It could be another owl that did it. And that is, as a scientist, that's a bummer. As somebody who lives in the neighborhood, it's just funny. I do want to say, in terms of ways to count birds, here is a Google Trends analysis of the words owl attacks. And I was quite, let's see if I can get the laser. Is that the laser? No, that's not the laser. Oh, that's not the laser. The center. Okay. So here is Ron Jakes' attack right there. We have the highest news trend on owls attack ever. And this is in February. And then in January, we had another cycle of attacks over on the other side of the Capitol, which, again, we don't know if it was the same owl, different place. It could have been, but we don't know. The only other nationally trending spike is this one right here. This was in Chicago, where a chihuahua was taken by a owl. So different ways to count birds. Okay. Now, this bird, we're not going to get too deep into politics today, but this is sort of the ultimate individually marked bird. In some ways, we wish that every bird was bold, like Stephen Colbert Jr. Colbert, the report, now he's got a different show. He used to have this eagle that would fly in and be like, the thing that drives me crazy. Has anybody seen the Stephen Colbert show? The eagle flies in and it goes, which is a red-tailed hawk call, not an eagle call. So that's one problem. Another problem is the eagle's a little small. The wings are short, sort of like our chicken fountain. It's like a pygmy eagle, something odd. But imagining this super patriotic eagle with all of these distinguishing feathers that I would know that eagle versus another is a very exciting idea. And this probably is our highest, most heroic celebrity bird. Its story starts with the Institute for Wildlife Studies, and they were interested in tracking eagles in Southern California where they were struggling and starting to come back. So they tagged eagles with satellite tags, and these satellite tags, we're talking about a variety of tagging technology as you track birds. It flew up and down the Central Valley of California, the Willamette Valley, and up into Alaska and Canada. Colbert has this whole thing where he doesn't like Stephen Jr. going to Canada. Um, the bird, this celebrity bird flew right past Salem along the foothills, and one of the cool things in this moment that we are in history now is you can go and have a satellite tag bird. Genius that the wildlife researchers named it Stephen Colbert Jr. and then told him about it. So then he put out like a bounty. I want a picture of my bird. And so the entire world was out there, and then somebody found a picture of Stephen Colbert Jr., aka Blue 46. And here you can see the eagle that has this patagial wing tag, and then you can see that antenna sticking out of its back, a little backpack, and that's where those data are coming. Now it's really compelling. Until 15, 20 years ago, you couldn't get this kind of precise data of where a bird was and where it was not. You were completely reliant on resighting. So now we can get information. The problem is Stephen Colbert Jr.'s backpack batteries had gone dead. And so he's still hauling that thing around, and it's not producing any more data. He's been seen breeding, and everything's going good. He's got a family down in the Channel Islands and continues to migrate. So that's kind of a neat story. Now this bird, E7, she is the superhero, super athlete, the most extraordinary individual bird that we know of with regards to bird migration. She is here, the cover girl of a newsletter in New Zealand, and that's because you can see the little flag on her leg. She was originally tagged in Alaska. She and another group of birds, and you see how those satellite telemetry data are just going straight across the ocean. For 8 days and 7 nights, she flew straight from Alaska all the way to New Zealand, never landing, no water, never touching the ground. People thought it was impossible, just extraordinary. And it was a friend of mine, Bob Gill, who did the tagging. Here he is tagging another bird in that flock, D9. And Bob makes this great analogy. Everybody conjure in your mind the most extraordinary athlete you can think of. And then imagine doing this 8-day marathon. What would that look like? Bob suggests it looks like this. You start out as an extraordinary athlete, as a sumo wrestler. You've got amazing strength, amazing balance, amazing strategy, and a lot of fat, which you use strategically. And then you go for a week. And at the end of the race, you're like this. You're a lean, light elite marathoner or long distance bike racer, Tour de France kind of thing, and that you finish that race as a single person in a single week. So these are kinds of physiological tricks that are so profound that if we could understand how a bird could do that in a week, you can imagine the kinds of biomedical insights we could have for people or for other kinds of things. Really, really amazing bird, E7 and her kind. Now, I'm going to talk, oftentimes when I tell people I study Caspian terns, they think Arctic tern. And so we're going to talk about Arctic tern. Arctic tern is in this panel. It's right there. And I couldn't find a picture of a Caspian tern and an Arctic tern next to each other, but I have a picture of a Caspian tern and a Forster's tern, which is about the same size. Caspian tern, my tern, is the world's biggest tern. It is also the coolest and best and prettiest tern. It is not the tern that has the most extraordinary migration, although it has a really interesting migration. Arctic tern really is extraordinary as a population and, again, a number of individuals. Now look at this tern closely. Do you see its legs? It, again, is one of these mark birds, tiny little legs, but it's got a marker on its legs, one that you could see and sort of read, and then one on the left leg's a little bit bigger, and it's got a special kind of tag. Here is a colleague of mine in Sweden, and he is so happy. He's so happy, and he's got that little thing in his hand. It's the tag from one of these Arctic terns. This tag is called a light archival tag, and what it does is it's got a teeny little battery, and it really is conservative with energy. And once a day, it has a clock that turns on, and it says, record the angle of the light at noon. And it does that every single day, once a day. And then some wizards of math and angle analysis and algorithms are able to take this light sensor, here's a picture of a tiny little thing on the leg, And they're able to infer by the date and noon the angle of light where on the planet they are. Really amazing bit of technology. And so we know, we've known for a while, but now we know the individual birds are doing this annual migration from the Arctic to the Antarctic every single year. They fly. These are known as the birds of light. They breed in the Arctic summer, so they have like 20-hour days. Then they go through the tropics to the Antarctica and have 20-hour days. More hours of light than any other organism on life or on the planet. Really amazing. Now, this is the generalized, idealized form of what that migration looks like. These are what the data actually look like. And you can see different colors or different birds and different phases and different squiggliness. That's an integration of all the days of the year, and you can see a really neat pattern. So how far do they go? What is that like? Well, it's amazing. In 1 year, the bird that has gone the longest went 70,900 kilometers, or 59,500 miles to 81,000 kilometers. That's the range. It's 44,000 miles a year. If you do that times 34 years, which is the average lifespan of an Arctic tern, they're going back to the moon and Earth 3 times in their lifetime. And this is a bird that's smaller than a pigeon. This is just a tiny, amazing bird. Birds are awesome. Okay, now the Pfeifferstorch. This is the story of the unicorn bird, the special bird. There's a time, and relatively and well documented in written history, we don't know that birds migrate. Everybody knows that now. That's a foregone conclusion. Birds migrate. But up until the 1830s, we don't know that birds migrate. There's a whole bunch of competing hypotheses. They may actually fly to the moon. They may go seasonally. They go into the heavens, and then they come back down seasonally. We see them flying off at night. It could be that they go underwater. It could be that they're hibernating different places. It is so here we are. We're in a cold, wet day in the Bavarian fields of Count Mecklenburg, and here in the field arrives this bird. This is the Pfeifferstorch, or the Arrowstorch of Mecklenburg. It is with this bird that in 1834 scientists validate for the first time that birds migrate. And they know because it has an arrow or a small spear through its neck, and it's an African arrow. And they know culturally that this arrow comes from Chad. And so there's no way that bird was from Germany. It flew all the way from Chad to Germany, and then the Count shot it and killed it and stuffed it. This is such a fascination and such a big deal at this point that people counterfeit Pfeifferstorchs because this is in a museum, and for a number of years this is like a super extraordinary piece of science. Okay. Today, you don't have to shoot storks with arrows. You can put satellite tags on them. You can get an app. You can track. This is a nest full of storks, and now Caramel is one, and we can track them, and we can see here is a citizen science. People in Germany are following, and you can see a bird marked in Germany came from Chad. So the same sort of routes, that hypothesis that the arrow was from Chad, and culturally, we can get that in real time now with those satellite tags. Birds are still doing that. Really, again, extraordinary. One other hypothesis, and what I'm going to talk about the longest to date research project, is one on swallows. So one of the earliest hypotheses of where birds went was they hibernated in the mud. And this is a wood cutting from a book in the 14th century where some Norwegian fishermen are pulling up herring and swallows together in the mud. And the reality of this picture then biases people's thinking for 300 years. This expert said it was so, and I saw the picture, and so that goes and influences, and we don't have any other data for a long time. At Cornell University, I've been working on tree swallows, not because I care about tree swallows, but because tree swallows migrate, and my friend who does tree swallow has some cool toys that I'm going to talk about. So these are tree swallows, 2 males, being a little sassy, and the reason that set of fishermen and swallows in the mud wasn't so crazy is in the fall and winter, swallows do gather around marshes, and then they just disappear. And then sometimes people would find dead swallows in the peat bogs, and so maybe some just didn't come out of the mud. So it wasn't a completely crazy idea. Uh, Take a close look at this dead swallow. Does anybody see the band on the leg? And then do you see the little wisp behind it? So this is a bird, a tree swallow, conventionally banded, and then it has a brand new invented kind of tag on it that solves some of the problems that of batteries going dead. So we're going to talk about, and this is why I want to go to Cornell University. I want to study Caspian terns. That's my new thing I'm doing all the time, but I want the toys that they have at Cornell. This is that same dead swallow, and what it had on it was the very first new generation of tag. And in the lower left-hand corner, you can see one of those tags invented by my friend David Winkler. And it is a teeny little solar panel connected to a chip with a capacitor, so no battery. Anytime the sun shines on it, it does a little radio signal. This is really tiny, so the idea is this could last the entire lifetime of a bird, and the battery would never go dead. And we could do some special kinds of questions. So the tags were prototypes were made at the very end of 2014, and the bird that died got hit by a car. It came back, went and migrated away, came back, and got hit by a car. I found it, and so inspected it. So we're going to talk about this particular story and this technology. The tags are being invented and made at Cornell right now. The tag, and each one weighs less than a gram. Beneath that is the size of the tag I put on Caspian terns, these big, huge satellite tags. The adult terns are good at carrying these big tags, but I've always felt ethically, I was uncomfortable putting on young birds because they're just not very good at flying. So I've been waiting for a new tag so I could go and do new migration. So here, this is the tag. Cornell is absolutely crazy in terms of the way that they study birds. This is a set of ponds at the Cornell Lab of Ornithology, and my colleagues here on the lower right, they have a huge cart. Those ponds are surrounded by a network of computers and Wi-Fi and Bluetooth, and the bird boxes, you can see the little blue wire. If you look in them, we'll look inside a box here in a minute. Other things about this particular place, they cut the grass so you don't even have to get like wet shoes when you go out to check the bird boxes. They have towers, you can see everything. They have a big, huge bug sucker, so if you want to know how many bugs are in the air, they suck those down and you can analyze those. Amazing. Birds have all kinds of tags on them, little RFID, so if they're going out of the box, we know where they are. You can analyze the blood right there at the lab. It's really amazing. What we're doing when we go to these boxes, we're looking at the ponds. There's birds both on the water and on land. And here's a colleague looking in, and you can see a beautiful turkey feather on top of these little baby tree swallows. Here's what the boxes are really amazing. So all of those computers and all that monitoring, there's a camera on many of the boxes. There's a refrigerator or heater on each one of the boxes. They're modeling climate change so that we can find out what would happen if birds were in 1 degree warmer or 1 degree colder. And how would that affect the development of baby tree swallows? And you can see these baby naked tree swallows, and there's one real egg, and then there's one computer egg. You can see the one on the bottom of the screen, and it's helping monitor those things. Really sophisticated experimental work. All of those kinds of measurements of the environment and the bugs and the birds is partnered with measuring the actual birds, and we pull those little boxes out of the nest and then measure their things like their beak growth. You can see the bird on the right has a little green dot, and then on the left, we're taking some blood from the wing. This green dot bird had been marked because it had been given a little bit of testosterone. So we're adding some hormones to its body to sort of see how does that change its behavior. So really, really sophisticated stuff that they could do at Cornell. The main thing I was doing in the last couple summers is using these tags, cutting edge technology, we're making them, and then we use craft supplies, stretch magic string to tie these things on. Here are the tags. Really, really, it's like doing a little bit of like surgery or sewing. You try to fit this on the bird, a little bit of glue, and then we're very happy because we have these tags. These are young of the year, so these are just about 10 days old. And then here's an adult. The theory, I'll let this bird go, and then I'll be able to track it with the antenna, which is in my hand, and then the the thing here, this is a base station that has an antenna, and so it's just monitoring their air all the time. And then the chicks, when we put them back in the box, one of the experiments we were doing with the hormones was if you give a bird a little bit of testosterone, will it leave the nest earlier? And remember, I told you these tags are, if the sun shines on it, then it fires away. So they're in the box, and so we can get the moment they come out of the box with these particular tags because we have that base station. So this is one of the experiments we did. We're still analyzing the data, but it looks like testosterone does make them more feisty, and they do leave earlier. One of the other things that we were doing with new technology, here's a little Pfeiffer stork. I put a tag on that bird. We set tags out. We took a variety of readers to make sure that the system was working. We put tags out in the environment to see how they did. This is a tag that's on top of one of the boxes. On the right hand, there's moisture in the tag. Not good. The tag didn't work. Each tag's about $200 and a bunch of people's time. Very frustrating. So the next research project is, which is better to dry them out, a light or putting them in the oven? I hope I don't burn up $200 a tag. Very nerve-wracking. But we figured it out. Other times, for me, I had never worked with engineers before, and so things weren't working, and we'd have to call the engineer out, and a guy with a laptop in the grass. It just seems so funny to me. I ended up learning how to do soldering and fixing stuff. This is sort of what sabbaticals are about, I think, learning new skills. I was part of an engineering group where we would work on making a new antenna. I had to learn who knew there's a theory of the antenna? And there's a book this thick on the theory of the antenna, and I got to read it so I could understand birds better. That wasn't so fun. It was fun thinking, like, how can we model the tags and what the birds are doing? So we put tags on boats, we put tags in hot air balloons, and then tracked them. We drove around Ithaca with antennas sticking out of our car, and thumbs up if you could hear the bird, thumbs up if you couldn't. And then we went to areas where birds might be and saw if we could find them in and around Ithaca, and we found a few. And this is the kind of thing we're looking for, these aggregating flocks. The Cornell Lab of Ornithology had previously, from those little teeny leg bands, knew this was what we knew about tree swallow migration and where they went. Birds from the north go south, and if you see lots of birds go to Florida. And so we had a hypothesis, what if we go to Florida in January and see if we can find any of our tag birds, our special tag birds? That would be really, really big. So to alligator country we went, and we went to, the question is, where do you go in Florida? How do you find tree swallows in Florida? Well, we use Doppler weather radar. Because tree swallows gather in flocks of millions sometimes, there's probably about 20 million total. Flocks of 8 million have been seen in Florida and the Caribbean. We would look for big, huge circles like this. And in the past, people had shown through weather radar that was groups of birds coming up in the morning. So every day we would look, every middle of the day, we'd look at the previous morning and see, are there any big donuts of potential birds? And then we would look at a program called eBird that we'll talk about after the break more, and see, did anybody actually see swallows there? And then we would go to that place and see if we saw swallows there. This is the way that the data are presented. And then we would see if we could find them. It was like we were a combination of tornado chasers looking for needles in the haystack. Because we have brand new technology. We don't even know if our needles work. I mean, it's pretty funny. This was the moment. This is what discovery looks like. We're driving down the interstate, again, with our antennas out of the window all the time because we don't know where we're going to find them, and we see the numbers pop up. We jump out, and we go and we get our first tags. It is really, really exciting. Dangerous, but exciting. This is a toll road. You're not supposed to pull over. The police eventually came. We met the police a lot in Florida. It was kind of like a Carl Hiaasen novel where they were like, we were part of the weirdness of Florida. This is at nighttime and my colleagues being held by a private security firm because we were looking weird, and so I have to talk them out. It's not all fun. Sometimes we're out in the rain. Really funny. But a lot of times it was just amazing. And I want to show you what I need to go to the video here. What swallows look like at night here. So here you can just this is sunset at a lake in Florida with thousands and thousands of swallows flying around there. Woo. And then me narrating. So this is just one of these great benefits of being a bird researcher and watching beautiful stuff. Okay, let's go back to the show. Okay, so let's come back to Willamette University and Caspian terns. See how we're doing on time. This is me and Aaron Riebel, a recent grad with some Caspian tern decoys, and the swallows were really interesting because they migrate. They have some new technology, and then one of the reasons I got to do the work is I helped collaborate a really low tech way of finding birds. Again, based on this unicorn / Pfeiffer stork bird. This is a bird that I tagged, and then and it was in the early days of the photo sharing and just before Facebook. I was looking around, getting ready to give a talk about Caspian terns to a group like this, and I wanted to find a banded tern, and someone had posted this in a newsletter in Sacramento, and when I got a hold of the person, they had taken the picture 3 weeks after I had banded the bird in Oregon. And so it was so amazing because this is a hatchier bird. It's one that I had done some measurements on. And so it was great to know that it had made it at least to Sacramento. So I thought, how many more of these could I find? And so I just started stalking the internet and looking for other photos. And I found a lot, and I'll show you more. Just this weekend, giving talks like this, then people say they see pictures, former student, hey, professor, today I was at a parking lot in the mouth of the Columbia, and I found some birds. And so here's some tagged birds. Here's a bird, one of the two birds that Molly saw 2 weekends ago, or this last weekend on Saturday. And then I had marked it 2 weeks earlier. And so here I am banding Caspian terns at East Sand Island, and then here it is off Colony. This is super exciting because the way we band Caspian terns, these ones in my hand weren't able to fly. Right before they could fly, we go onto the colony, we catch them, we put these tags on, and then we leave. It's very stressful for the colony, very stressful for the parents. So when Molly sent this picture, it was validation that the bird fledged, it got off the island, and it was on its way. So really, really exciting. This crowdsourcing or finding photos that other people have and then inviting them to share photos has really turned out to be extraordinary in terms of the way in which people oftentimes who don't even intend to help study bird migration are helping. And so I started two groups, one just pictures of Caspian terns, and then another one of actual birds with bands on their legs. And so if you ever see a bird with something on it, let me know, because one of my friends has probably tagged it. And if it's a Caspian tern, I'm interested. We started out with just a few birds, and now it's hundreds of birds and approaching 1,000 that we found this way. Really, really low impact. And I also feel a certain kind of moral rightness in doing this kind of recovery because we have burdened these birds with our questions, and in a way that hope we can sort of get the most out of it. I'm going to close with I'm going to change topics. There's a lot of questions in the world right now about our place in nature and our relationship to birds and all kinds of nature. There's also lots of new technology that allow us to watch. And so right now, the state-of-the-art surveillance, it's super creepy / awesome, is in our most endangered birds. So California condors right now, birds like Green 99, every single moment of its life now is under surveillance. It's from its egg to its hatching. It's got a camera on it. You can go and help code the data of when its parents came and fed it. It's got satellite tags on wherever it goes now. We can know where it is, and then we'll know about its reproduction, and that you can participate and watch all this. That's sad in some ways that we're at that level of monitoring, but the upside is I think it could kind of be the end of zoos. It's like, who needs to go to the zoo when you can see like a real condor? Wow, then you can go and know where it is and go find it. If this has just been a totally horribly boring talk for you because you don't like birds, I'm sorry. There is a way in which this kind of work, though, might contribute to things you do care about in terms of human health. One of my favorite non-science person stories. A person took pictures of these bar-headed geese in India because it was a pretty picture of geese, and noticed that neck collar in the bird in the lower left. Wanted to find out what that was, and it turned out to be the first connection between wild areas in which bird flu were in Mongolia and connection to a bird to a high population area in India. And so there had been a question of like, could wild birds be spreading bird flu? And the answer is yes. Again, that was, and scientists put satellite tags on, all kinds of GPS tags, hadn't got that. There's lots and lots of kinds of apps. After the break, we'll go and look at one of them, eBird, on how to track whatever kinds of nature things you want. I just put this in for the TED Talk because it was funny. You can track anything you want. Kinsey Report. You know what that's about. This is a picture I drew for myself about what my sabbatical was going to be about. I like to do a little bit of art side, so this is me sort of tagging a turn and thinking about their lives and new ways to understand that. And I will open it up for questions. Now it's your turn. Ha ha ha. So that is the official opening to all bad turn puns. Please bring them on.
Thank you, David. I'm interested in the water ouzel.
Yes.
How much do you know about that bird? Is it flourishing, or what's happening to it? Because we're doing a lot to the waters now.
Yeah, great. Any question about any bird? I didn't talk about water ouzels at all, but so water ouzel is a great special bird, also called American dipper, or the dipper. It's a bird that it is the only songbird that is aquatic. It's the only songbird that can swim. And it has this beautiful song. If you've gone to Silver Creek Falls, one of the best places to see it, it is under some conservation jeopardy because of the changing water regimes and sort of the general drought and those kinds of things, and then the quality of waters going down. And the place is good habitat; they do great, but they're not in the top 50 birds that we're worried about, but they're in the top 150. And there's about 900 in North America. Yeah.
This is Joyce.
Hi, Joyce.
Hi. I was interested in your injection of testosterone
Yeah.
in that experiment, and you mentioned that it did tend to have them leave the nest a little earlier, but would there be any other reasons that you would have done that kind of experiment?
There's a lot of reasons, and thanks for asking. So one of the reasons we're interested in doing that manipulation was looking at the success. So we wanted to look at, is it more successful to leave the nest box early among your siblings? And there was some suggestion that there are sometimes advantages. There's sex differences between males and females, and so we wanted to see, what are the consequences? So there's a variety of long ongoing studies, like, is it, if you get out of the nest first, then do you also make it to the migration grounds first, and then do you come back as a breeder earlier? And so there's a series of experiments by doing manipulations at different life stages of like when you change the bird's behavior and then see what happens next, are open questions. And so what that particular experiment was looking at was the nests that had the manipulation of them leaving earlier, then how long did they stay in the breeding area before they migrated? Did they just leave the box early and then stay in the area? Or did they leave the box and then straight away start to migrate? And what turned out, what is males, we knew typically leave the migration area earlier. And so that turned out to be for these testosterone treated birds, they left the boxes earlier and then they did leave the migration earlier. So it was a way to go and look at that was one of the mechanisms. Does that answer your question? Yeah.
Hi, this is Cassia.
I can see.
I had great fun this spring and into early summer watching the Eagle Cam at the Washington, D.C. National Arboretum.
Yeah.
These are bald eagles, American eagles. And it started out with a male and female. The male was called the president, and the female was called TPL, or the First Lady, TFL, the First Lady. And they eventually had two chicks. You could watch them hatch and develop little feathers and watch the parents come in and feed them. And the two chicks were named Liberty and Freedom. What else? And eventually watched them get bigger and bigger every day. I mean, it was amazing. You just watch this on your computer screen, and if you could get stuck watching them all day, actually, watching these things. And eventually they grew up to be big enough where you could watch them take their first little hops, and then they'd hop up onto a branch, and then finally one day one of them flew away, and the parents never came back. And so I'm wondering, they didn't appear to eat once the parents went away. What do they do? How do they eat?
How do the young eat?
Yeah. They're sitting on a branch, and they're looking out, and they're not flying yet.
Yeah.
So what happens?
That's a great question. So in eagles and in many other birds, parents will go and a common misperception is that young birds are smaller than the adults. And so you'll see us almost in all, most birds that grow up and spend a lot of time in a nest, by the time they leave the nest, they weigh more than their parents. Oftentimes their wing feathers may not be as long, but they actually weigh more. So parents fatten them up. So when they don't know how to feed, the kids have got a little bit of a buffer. And so as they go and figure that out, then many species will go and continue to have short or long periods of extended parental care where they do feed, but it could have been the kind of thing that was happening outside of the camera view. Eagles are one that it is definitely one of the strategies of the parents to cut off the food to get the kid to leave. So those eagle chicks get big, and heavy. And they don't want to leave. It's like, why would they have to go anywhere if parents are bringing them fish all the time? And so the parents will go and stop feeding, and they'll be out there branching. And they're really, if it's osprey, they're really, really noisy. That's a pretty common thing. And and so the parents will then in eagles and in osprey, both, they will oftentimes go and carry food, which is a normal part of their life, but they'll go and they'll basically kind of like tease the kids away. It's like, oh, no, you want this little rabbit or you want this fish? Come with me. And so then they'll go and then they'll drop it, and oftentimes the kids will practice catching it. So there's a little bit of training and learning. Eagles, owls, and start breeding really early. So because that learning how to do that takes so long. So they start courting in December, January. They'll be on eggs in March oftentimes, and then kids will be doing this kind of fledging in April, May, so they have a whole summer to figure it out before summertime, before wintertime comes. So yeah, good question. One of the things about the cams, this new camera opportunity we have to watch all these birds, it's provoking new people who didn't care that much before, sort of like reality TV. You didn't really care about this one family or this one group of people trying to lose weight or whatever, but you get hooked. And so then you start watching, and people do it in complete ignorance. So they're seeing this like all happy, and they're named the president and the first lady, and then nature happens. So then this was a happy story, a very conventional story, but there's been some major problems for the scientists running those cameras when, let's say, the osprey mother, the food is collapsing, the reservoir has been drained, so she just butchers her children. Because she's like, well, I got to finish my reproductive effort. And so or two siblings, the bigger one will kill the younger one. And you'll watch this slowly peck to death. One, and it's like, turn off the camera. But that's this is what happens normally. Or there's all of these extraordinary rare events that now have been captured many times of the gray-horned owl that comes in and snatches the osprey chick off, or the eagle that comes and snatches the owl off the nest. And so this happens in a second, but these are, I was afraid you were going to bring up one of those stories. So since you didn't, I thought I'd share it. Yeah.
Hi, I'm Roz.
Hi, Roz.
Some years ago, there was an effort by some wildlife management agency, I can't remember who, to locate terns at the mouth of the Columbia.
Yes. Yep.
And those may have been Caspian.
It was.
To try to, I think, so they wouldn't eat the young salmon. So could you comment on that effort, how it's gone, but also the larger issue of humans trying to modify
Yeah.
bird behavior?
Great question. So the original reason to ban Caspian terns, which I started doing in 1997, was part of that colony movement, and it was the terns breeding at the mouth of Columbia were the first observation was some migrating salmon that were tagged. 40% of the tags, they had these little belly tags, these little radio tags, and the scientists following those salmon, 40% of the birds that, or the fish that they had marked showed up on this bird colony. They thought they were seagulls. They didn't realize it was awesome Caspian terns. But they're like, this is bad. These are bad birds. These were really big tags in the fish, and so it turned out that the fish weren't very happy and healthy, more vulnerable to predation. But that started the whole question. So the current climate of wildlife management is there's lots and lots of stakeholders. People want to save the salmon, and people want to protect the birds. And so one of the things why we started tagging the birds was find out exactly how many birds are there, and then how many fish are they eating, and then what are they doing. And one of the ways to know, the same way that I framed Al Capone as a great story, really exciting, but we can't really use his experiences scientifically. So it was with Caspian terns. We need to mark them with those leg bands so we know exactly how many fish did Kevin eat or Amanda eat. And then we could go and make models. We know that there's 10,000 birds. Kevin ate this many. Amanda ate that many. And then we can figure that out. So that's part of why we mark them. Also, when the birds, if we want to move them from one spot to another, how do we know we've been successful in getting them to move? And then in the same way, we have demographic models that we use for insurance to figure out who's the most vulnerable to certain kinds of accidents. We do that same with the tern population. In a year that there's a lot of chicks, then we can project in the future there'll be more or less birds. The movement of the Caspian tern colony was a wild success in terms of saving salmon. There's been a lot of things that are probably good for the tern population. It's been distributed throughout the Western North America so that it's less vulnerable to a single disease or a single vigilante or a single predator. So those things are good. My personal sense is I wish that people were able to think about ecosystems and work at that scale of management, but people aren't. And so we're kind of stuck with these parts and doing the best we can. Part of why I like being an educator and I like these kinds of questions is like, we need lots more people who care about it and more education to think about it so we can make better policy decisions. Sometimes as a scientist, I can give you lots of details, but if you don't want to use them, then that's sort of where society is. So, yeah.
Hi, this is Scott Reichlin.
Hi, Scott.
I was interested in the long migrations without any food or water.
Yeah.
And I was wondering, in general, do birds drop down to, if they're going over land, for example, do they drop down for food or water? And there was one that the bird, I forget which the one that went from the North Pole to the South Pole.
Yeah.
And it looked from the map as though it paralleled the coasts in general, so
Yep.
South Africa or Africa or South America. And does that is there any significance to that in terms of whether it may be looking for shallow waters where they can get fish or some source of water?
Great set of questions. So the bird that made the big flight across the long distance, that was the bar-tailed godwit. I'm not sure I mentioned that. And that particular bird, we had no idea that it could do that. One of the things that I didn't highlight is it didn't fly, those godwits didn't fly straight from Alaska to New Zealand. They kind of had to fly out at an angle and then bend down. So they don't take the most direct route. The staggering thing, when they analyze what is it that they're targeting out there in that spot, what's the big turn, it was the jet stream. And so those birds fly out, somehow know the jet stream is there, and then it helps carry them down. The jet streams are not always predictable, though. So you can imagine a bird flying out, no jet stream, and then they have to keep flying. So those are the kinds of things that these kinds of data allow us to, like, we didn't know they did where they went or how they got there. We knew where they started, where they ended, but didn't know how they did it. So right away when you get the pattern of the movement, then you say, what's there? The Arctic tern, which is the one that you noted was following those coastlines, it's following major currents, ocean currents, and then it is tracking a variety of food resources. And the terns are able to and do land on water, and they do like those shallower, safer water. So that's part of their migration. Yeah, great questions. And the amount of atmospheric data and other kinds of natural resource data we can relate those pathways to is huge computational tricking on the computer side, but it's allowing to answer some of those questions. Great.
Well, thank you very much. We'll take a 10-minute break. Back for the second half.
So what I want to show you is this. I've got a set of slides about how to use eBird, but what I'm going to, and I don't know if there's a way for me to make that available. It's how to set it up and how to do it. I don't want to give another formal talk. We're going to do I'm going to take a list of birds people have asked questions about, and I'm going to show you how awesome this tool eBird is. The basic model is, if you see a bird and you record where it is and you put it on your computer, it automatically shares it with everybody else who's part of this eBird community, this program. And you can see every bird that they saw, when and where they saw it, and it creates new kinds of data, and it's happening all over the world. If you are a smartphone user, you can take an app, and you can go and on your phone, you could say, right now I see 300 Vos swifts going down the chimney at my neighbor's house. And you can put that in there, and then everybody can know that you saw that. And a Vos swift biologist could go and get that data and all of the comparable kinds of data. It is a way in which when I organize projects now, eBird is the way that I'm coordinating people to share Caspian tern observations, but I can look at Caspian terns all over the world. So there's a whole bunch of ways we can look at this data. And so since we started with Caspian terns, what I'm going to do is just show a couple different species and what you can see in eBird and what it looks like, and then we'll look at American dipper, Vos swifts, osprey. Somebody asked, when are the osprey going to leave? You can answer that question with eBird. Where are there lots of swifts? Where could I see swifts? We could look at that. Caspian terns. Where do Caspian terns live? Let's do that. Okay, Dave. So we can look at species map. We'll start with species maps. And so here's the whole world, and I'm going to type in Caspian tern. Caspian. There is nothing known as the Caspian tern. Caspian, okay. Okay, Caspian tern. And then right now it's giving data for all years, all round, and these purple dots, it's a concentration of, darkest purple is 40 to 100% of the people who counted birds, any kind of bird, in that place at that time, saw a Caspian tern. And then the farther you go down, the less common it is. You'll notice here we're in North America, and if we look, this is for all years, you can start to get a sense of, like, where are Caspian terns? Well, there can be anywhere, and all the way up into Alaska a little bit, these Great Lakes, and around down into Mexico, into South America. If we look over in Europe, they're there. In Africa, there are very few dots, and this is a bias in the number of reporters. So there are many more Caspian terns there, but this is a bias of the system because we have relatively few people who know about eBird. If you go to places like South Africa that are more developed, places around Cape Town, you get lots of data. So eBird does a lot. If we go to, again, highly developed places throughout the Middle East, lots of Caspian terns throughout Eurasia, Australia, New Zealand, out in the islands. Caspian terns are cosmopolitan. The only place that they are not is Antarctica. They're not in most of South America, which is one of the big questions that I'm going to work on in the next 10 years. Why don't they go to South America? They're in Africa. Why not South America? They're all over the planet. Why not there? And I've got some wild ideas, but not any idea. Now let's look at right now. Let's look at just the month of September. We'll see it's going to change. Set the Danes rate. So you can see it contracted some in North America. Let's go to, let's plan winter break. Let's go to December. Where should I go for some sunshine and some Caspian terns? Oh, Mexico. And there could be, one of the interesting things, there's a few stragglers, but if we look versus all year versus what time of the year, we can see that there's concentrations. And so this is the kind of thing that I have been doing. I have these sophisticated, expensive, few individual birds tagged with really expensive technology, but then I can look at this crowdsourced data. And if we zoom in, the closer we get, these purple blocks start to turn into dots. And these are then the actual reports that somebody put. And you just saw me make this up, so I have no idea what we're going to get. But this looks like a really nice beach. And here's an Airbnb right there, San Blas. So we'll just hit this, and we'll see. Okay, here's a guy named Tom and a guy named Steve and a guy named Richard. And they saw Caspian terns, or they saw 6 terns on in 1973. This is cool. So they put in data from a long time ago. This is one of the things that they didn't do this on an iPhone. But this is great. This is the kind of thing that's happening where your old notes can turn into data. And so they not only saw Caspian terns, they saw a whole bunch of other birds. You can imagine a project where you're like, what are the species that Caspian terns associate with? And you could compare it through different periods of time. So that is one thing we can do with Caspian terns and eBird. Let's look at just the last. Let's look at just this September. Let's say I want to go and find out people, and one of the things I could do is say, okay, I want to see people who saw Caspian terns in September, and then I want to correspond with them and say, hey, did you happen to see any with bands on their legs? And if you did, do you have any pictures? I'd like them. And we can see, here's right in the Willamette Valley. This is just in the last month. Does anybody know Michael Connor or Sean Burns? See what else they saw. So here they've got, again, they're just going out bird watching, putting everything that they see, and then it included Caspian terns, 5 Caspian terns. They're not Caspian tern researchers, but they're really, really valuable to me. And then I can go into the little communication system and communicate with this person that I haven't met. Let's see. Now let's look at. We should probably do this for like 4 hours. No, we'll switch. I love Caspian terns. We're going to switch to osprey. Osprey is a little more conventionally likable species. Well, let's go to osprey. And osprey are really compelling to me. Oh, now we're just looking at September again, so you can see that they're throughout North America and throughout Europe. Interesting, they're leaving Europe faster. Let's look at year round. So everybody see how the osprey distribution all over North America, into South America, farther into South America, and then across Africa, across Europe, across Asia, Australia, New Zealand. To me, this is really interesting. In all of the birds in the world that have this cosmopolitan distribution, there's only about 8 that are in this group: osprey, peregrine falcon, barn owl, Caspian tern, gullible tern, and roseate tern are sort of and cattle egret are the world's most naturally occurring, globally distributed birds. So then the question, and think about it, birds can fly. Why aren't all birds everywhere, right? That's a pretty big kind of theoretical question. And so then it comes down to their behavior. How far can they fly? I showed you today that, and then why does a bird that can fly all around the world from the Arctic to the Antarctic, why does it only breed in the Arctic? Or the bar-tailed godwit, why fly all the way across from Alaska to New Zealand? That bird could clearly breed anywhere in the world, and it doesn't. So we can't do the experiment of why it doesn't do something if it's not doing it. We can think about it. We can drink a lot of beer with our friends. Well, I think this, I think that. And so Caspian tern and osprey and a couple of birds, I think, are in an interesting evolutionary moment that they still use all of the world, or they're doing something that they haven't differentiated into the normal thing, which is just be the eagle of your continent, be the American eagle or the Steller sea eagle or something like that. They're not doing that. They're doing something else. So these kinds of crowdsourced data then allow me to start to explore that question in a way that I couldn't do otherwise, because these are real data. They're not just sort of models in a book. The question was, how long are the osprey going to be in Salem? So we could just go through, and you could be a scientist on your own and start testing hypotheses. Let's look at, will they be here in October? And if we look at October, and we could say, we're going to say just in the last, we'll do this year, no, we'll go, let's say the last 3 years, in October, do we have osprey in Salem? The answer is yes. How about in November? The answer should be no. Oh, dang it. Okay, how about December? Yeah, if we looked at the numbers, they'd be decreased. Well, so there must be a few resident birds hanging around. See, this is one of those things where I didn't know that, but let's go back. Let's look at Salem. I was looking too broad. This is the kind of thing, too, as a scientist, I'd be like, okay, Bobby, tell me about this osprey you saw in December. On Christmas. That's kind of, what were you doing? Okay. See, and I'll just tell you right away, this does, and this is the kind of thing that I do, is, and it's like, right away when I look at this, it's like, I don't like, I like that Bobby contributed to eBird, good, but all of these X's that they didn't put in numbers for all the birds calls into question the overall quality of the data. Why did you have numbers for some and not for others? So I could go and download all of the data for Caspian terns, all of the data for osprey, and then say, remove anybody who didn't have a number for all of the birds that they saw, because I don't want to have data like this, because I need to compare real numbers to real numbers. Doesn't mean that Bobby didn't see it. It means I just don't want to use that data because it's too complicated. Okay, let's look at another. And then one thing, Larry was asking about dippers. Let's look at them. Whoa. The typo went to a large ostrich of. There's this funny thing. So those of you who are presenters, educators, you know, it's like you go to the board and try to write your own name, and you can't do it. So I try to type in front of a few people, and okay. So, and then raise your hand if you don't know what an American dipper looks like. Okay, good. Cornell Lab to the rescue. So the Cornell Lab of Ornithology was a early adopter of the web, and they have this extraordinary website. It's the single best place, sort of as a go-to place to get information about birds. And so that's what this bird looks like. And then they have partnered with the American Ornithologists Union, the society, which went through and did this really big comprehensive scientific review of each species. And we have this official reference that we use called the Birds of North America. And they've pulled out a lot of the neat material from that to share with the public. And so we could go and be looking around, asking questions about where are these birds? What do they look like? So let's answer the question first. Where are they? And where could I go see one of these? And if you look, Silver Falls is a great spot, just like I said. But here's some other place we could go that's a little off the road and find some creek and go. Oh, David, what do you? I didn't know that. That just happened. That's too funny. That was a really good day. I showed my niece, who was 5, a dipper for the first time right there. That was fun. Well, golly. I do use this app a lot. So here's places you can look at. And the bigger the blue thing, then the more times that the bird has been seen there. So this is a thing you can do. Let's and that's to see it in December, but you can find the different months. Let's take a look at what do these things look like. They're very black and hard to see. No. I'm going to put the mic down here by the computer. Everybody sees that really cool pump, 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 right? So there's a couple of birds, spotted sandpiper is another one that have this same habit of like picking along the edges of water habitats, and then they do this bobbing. And there's some hypotheses that maybe they're using it to triangulate and sort of look underneath the water, deal with the glare. But this is one of these neat observations that's still kind of a mystery. That we don't know about. I'm going to play the song too, and then we'll move on to another species. The sound is awesome. It's not you. It's So that part of the awesomeness of that song you might not appreciate. So part of it is you heard the water in the background, and then you heard the whistling. People have looked at the frequency of the water splashing and discovered that dippers choose notes that best complement or are out of the competing register of the water splash. Isn't that amazing? So when they're in that space, they can hear each other better because they chose the right notes. Other birds singing around the water that aren't co-evolved in that habitat in terms of their courtship sing, and they get drowned out a little bit by that. And so dippers are really, really specialized. And so it's a nice song, but then when you know about the trick that they're doing to make it so accessible, it's really, really quite amazing. Okay, let's go back to eBird. Here's some other functions. I'm not a lister, but you can keep a track of all the birds you've seen. Those extraordinary people that I was working with at Cornell, they use eBird all the time, and I had sort of been a so-so lister, and luckily I'm an old person to them. All those people, they were like all in their 20s, and so since I was in my 40s, they're like, yeah, you're too old to know how to use eBird and how to really be cool. But like young people that are really into Twitter and Snapchat and Facebook and live streaming and video, all that kind of stuff, or Vine, the young 20-year-old bird person today, hi, my name is Dave, and they'll be like, oh yeah, is that your eBird name? Oh no, I go by Raptor 7. Oh, cool. And then I'm over here on my phone, I'm like checking out Raptor 7, and I'm like, okay, what's your list like? And see how many birds you've seen and where you've seen them. And then I'm like, oh, Raptor 7, you've 700 species. So there's this way in which the competitiveness of people is being driven to make this work even better. So then sometimes people meet up around some unusual bird, and that they've known each other for 4 or 5 years, and they've been following each other, and they didn't use their real names, and so they sort of meet in the analog world around some bird. I think it's pretty neat. I go through these little fits of getting my list updated, and I'll be one of those people who puts my stuff back to 1974 when I first started watching birds and keeping track, so that when I meet 20-year-olds, they'll be like, oh, Dave Craig, well, you've got a... I know I've seen over like 1,000 species of bird, maybe 2,000 around the world, but I only have 300 in my life list right now. So they'll be like, well, he's really good on crows and terns, but that's not really what we're into. And I want to be cool. One of the things too, by virtue of using my smartphone, it goes and it records the place that I am automatically. And then it creates all of these lists. It does it by month, by year, by county. And then any kind of unit I want to make up, like my backyard or campus, I can create a special list for that. Here you can see I've been doing this just since my sabbatical, basically. So I went to Santa Fe for a little trip for the balloon festival. And I was thinking about balloons, not about birds, so I didn't do much counting. But on the coast, I've been doing a lot. Here's the trip to Florida when we were chasing the birds and talking to the police, and saw the different counties that I was at. Cornell this doesn't work on me, but some people, they'll go and they'll set up these contests, and if you get a bird count every day, 30 days in a row, you can enter in for like a pair of $1,000 binoculars. And so then people they go out and they do it. Or can you get birds in every county within the year? And so then people go out and do that. And there's a way to fill in the blank spots on the map. And there's social scientists and computer scientists who are using these awesome people who put this in as guinea pigs for all kinds of other kinds of work on, like, why would people do this? What time of day do they do it? How do they change as birders as they do it? So that's one of the ways to look at the list. We can look at exploring data. There's a way that you can do this is a new app. You can look at different pictures of things, and you can say, I want to see, let's say, I want to say Caspian terns, but yeah, I'm going to do Caspian terns. Laughing with me, not at me. I got that. Yeah. Okay. So this is for me, this is the kind of thing that I probably will turn on my students on. This is a new function that they just started to use, where you have photos combined with the app. So people are out taking a variety of pictures. You can see these are not beautiful pictures, right? They're not beautiful unless you're a nerd. This photo is gorgeous to me. Because right away, again, this is the kind of thing that you get with expertise. I know this bird is 18 months old by the color of its feathers. These feathers right here where the arrow cursor is, it had those as a chick on the colony when it left. And then these photos, these feathers, it grew, so those feathers right there are 1.5 years old. These feathers are 6 months old. So it molted these out, totally clean, new flying. I know without even, I don't, oh, Cusco, okay, interesting. Okay, so this bird went from someplace in the north, went south with this set of feathers and a bunch of feathers of the same age in Mexico or Venezuela. It dumped those, grew new feathers to migrate back, and then it spent the summer somewhere up here in the north, and then was seen in Coos Bay in the fall. So pretty interesting. I could go and take photos and look at the feather age and start to talk about the evolution of molt. Here's another cool picture. Ever see these missing feathers right there? That is also molt, and birds strategically molt their feathers. Makes sense, right, in terms of flying symmetrically. So if you lost this feather but not that feather, then your wings wouldn't be balanced. And so this is the kind of thing that if I followed photos of birds throughout the annual cycle, I could go and look at when are they molting certain feathers. Okay, and then if I look through these, I can probably find banded birds. Is that one banded? Maybe I just ankle. Okay, I'll do that on my own time. Showing you what scientists are really like. Let's look at this sound. Here's recording, so you can listen to. Let's just green warbler, Acadian flycatcher. That's it. That doesn't look like a very interesting call. Let's go back. Here you can see the call structures though that you can, and so you could listen to this. This sound right here, Great Kiskadee, it's going to be blank sound. This is static, and then it's going to be its name. It says its name. Then it's going to be like Kiskadee. Okay, you can play around with that. Explore a region. Let's say I want to look at Marion County. Did I miss it? Apparently, we're not that important. One of the things I love about having participated in eBird, it's about 12 years old, but just in the last couple of years, it's lots and lots of new things are happening. So if we look at Oregon, you can find out how many bird species are in the state of Oregon. 526 have been recorded. And we know that from 435,000 checklists, different lists that people put in. And then if you were the person to be the first to see something in the state, your name would be recorded forever. If we look at the bar charts, we can look at seasonally by month what's the probability of seeing different species. So Canada goose, you can see it any time of year, right? Obviously. Other birds like the cackling goose, the small goose that sometimes people think is a baby goose, that is more just in the wintertime, but not in the summer when it's up in the Arctic tundra breeding. If we look at other birds, let's look at, here's another way we could look at osprey, actually. We'll go down to osprey, Bob White. You can see the total greenness is how common it is. And so these wild turkey, resident year-round, loons, albatross, pelicans, osprey, broadwing hawk, original. Ibis. There's osprey. Okay, so here we can see osprey. It does appear that in Oregon, and we could shrink this to different areas, they are around, but my hypothesis that they would be gone in this time of year it's less likely. So this is one of the ways that if somebody says they see something, it's a good way to find out, well, is that possible or is that very likely this time of year? Okay. Let's go and look at one more function, my data, species map, bar graph, we did that. Here's another kind of cool map. You can see where people are submitting and just today, so 7,222 lists around the world. And then another good day for eBird. And then let's do Australia. So here you can see a couple different forms of the data, and then this is a month by month, and you can sort of see that seasonality. You can look at abundance, birds per hour, the average count, the high count, the totals. You can see it as a map. It'll download as a separate thing. And then you could download all this data, and let's say you had some ability to do statistics, you could start working on a project right now in terms of like things you wanted to know. And I'm afraid to do this, but I'm going to do it. If anybody starts playing around with data and they have some questions about any bird and they want some help, let me know. And then maybe I just won't return your phone calls after a while. Or maybe I'll be like, this is awesome. I think we've made a discovery. We might have to share this with other scientists. I think it could be good. I think I'm going to stop there and let you guys ask some questions, and it could be ones that we go and we do some more explorations. The great thing about eBird, it's got all kinds of online tutorials, YouTube stuff, and lots of users around. Yeah.
Hi, the name is Franca. I've been curious. I was in Central Asia and Kyrgyzstan at 10,000 feet in the winter.
Yeah.
And I found magpies. Only magpies. So what is up there that they can eat that would sustain them?
That's a great question. Let's type in magpie. Oh, man. Magpie. I'm gonna. The magpie has one of my favorite Latin binomials, pica pica. It's like gorilla gorilla or bison bison. So here's their distribution, and then if we look, let's just look. You said it was in the wintertime? Let's go in the wintertime. They're pretty resident sedentary birds. And then, let's see, did you say Kazakhstan? Oh, Kyrgyzstan. Okay, farther down here. Okay, great. So here we can get in here, and we can go and we're not going to do this right now, but we could just go and say, Jake, turn. What are they eating? Let's see if we can find somebody who's got some numbers. Okay, so these are people just doing lists. Interesting. These are all very English-looking names, which makes sense in terms of like the app is still mostly in the English language. So I don't know what they'd be eating there particularly, but I did do my PhD on corvids and the family of corvids, and I read a lot about magpies, and they were part of my dissertation in Colorado, where pica pica, the North American subspecies, is. One of the things that is extraordinary about magpies and crows and ravens, these birds are not very migratory, and they become sophisticated in knowing what the food sources are in their area, and they're very exploratory. So there's going to be some source of protein and seed that they're able to put together. The intelligence, one of the theories of their intelligence is related to their ability to go and figure out what to eat and how to remember that and how to know it. So so the next thing I would do is let's just go hazard since you asked. I'll show you how I do stuff. I would copy magpie, put it into Google, And then I would go back to the map because I don't remember how to spell Kyrgyzstan. Does anybody know how to spell it? How do you spell it? K-R-Y-G. Stan. Okay. Diet. So that's a start. Now we could do and here's how many, raise your hand if you have used Google Scholar as a search. Has anybody done that? Okay, this is we're gonna go to the next level of tricks here, because this is like a great way to look. In particular, you guys are so academic. So if we go to Google Scholar. It's just another search engine that they have that narrows it just to academic titles and papers. So we take that same thing, that same title, put it in Google Scholar, and I know we're going to get something different. So now we're getting down to really narrow groups of experts on this particular spot and diet, genetically similar. Something about owls, but if we get into this, it's going to have things about magpies, phylogeography of widespread corvids. That could probably have stuff about diets. This is how I would answer your question if we we're going to spend a little more time on it, and it's a great way to look. We also get discoveries about people eating walnuts, so that's neat. Okay, another question.
Dave, Bob, when you're working on the accuracy of the data that is being collected through eBird,
Yes.
how do you deal with you talked about underreporting. You had a suspicion concerning one person who didn't report, but there's also the accuracy of identification. So what protocols do you use to assure that the data you're getting is representative of the area?
That's a great question, and that's one of the things that the map and the time of year and then your using habits are one of the things that the folks at Cornell figured out how to look at. So they look at, and they built out and have scientifically sort of validated what's the probability that this user is identifying the right bird. And then if you see something extraordinary or unusual or a lot of something, when normally you only see a few, it automatically is flagged, and then a real person will go and correspond with you and say, it's great that you saw an ivory-billed woodpecker, but no one has seen one for 72 years, and so we need more evidence of what you had. And if you just say, well, this is what I look like, that's one that it wouldn't be good enough. But if you said you saw, let's say, a spotted owl in West Salem, that would get flagged because those haven't been there for a long time. But it's not impossible. And maybe you have a picture of a spotted owl. You took a picture. It wouldn't even have to be a good one. Then it could be validated. It's probably a barred owl, though. So that picture would help the expert validate. If it was a spotted owl and you found it, then the codes associated with your use behavior would be like, Bob's really good. He found a spotted owl in West Salem. And so then the more discoveries like that you made, then the stronger your profile is that you are an expert. And then the more times you go out at bird, the more that you get things, then the better it becomes. There's another thing for those who are still learning or want to learn more about birds. There's an app called Merlin, which is awesome and getting more awesome all the time. Merlin is a free app. It is a bird. It looks like a little falcon, but it allows you to say, I saw a big bird that was kind of yellowish, that had a lot of educational statements, and they'd be like, that's Big Bird of Sesame Street. I saw a little black bird that had a white stripe through its face, really flitty on the end of branches. It was April, and I was in Salem, and that would be like a black-throated gray warbler, or maybe a black and white warbler, and right down in two different things. This app again is free, and Cornell makes it available free because they want people to be better bird watchers, so they can go contribute to that data. if you're able to actually get a recording of the bird from your phone, or you put your phone out in your bird feeder and it's like making little noises, it will analyze the sound and match it to the sounds in the Bird Labs thing and say, this is for sure a house finch and not a purple finch, or this is a black-capped chickadee versus and stuff that if it's like you have an owl that's hooting out there and you're like, is this a gray horned owl or barred owl? And it's good enough, you can go and then have that checked in. You can also, if you have a lot of photos of birds too, there's a big project. How this works is people have those recordings, and the more recordings and the more photos that go into the database and then are coded, then we have people that go in and say, this is definitely a Caspian tern. It hasn't happened yet, but something that I can imagine having my students do is we'll go through and code all of those things I was showing you about the tern's molt, that these parts of the wing are this age versus that age. And in the future, you could get a photo, and right away it would go and tell you, oh, that's a 2-year-old tern, that's a 1-year-old tern, that's a 4-year-old tern. It can't do that yet, but it's easy to imagine that it could do in the future. So Merlin is a great app. We have a user. David's going to show his version of Merlin. I am so I'm going to be not humble here. I don't need Merlin. I know all the birds already. In North America, and when I went to South Africa, I needed the equivalent of Merlin. But great. Let's have another question while David gets his.
Okay. My name is Sally, and this is very basic, but what are the lifetimes of birds, and are they all different, or are they all about the same? Or
That's a wonderful question. The lifespan of birds varies a lot. The oldest known living bird right now is an albatross. Her name is Wisdom. She gets a lot of press every April to May because she also, at the age of 70, is still breeding. And so she's laid an egg. She was banded as a bird on Midway Atoll, and then she has we have a record of the many times that she has bred, and so it's always exciting when Wisdom comes back. She's the oldest known living bird, and then lots of birds have birds in your yard, songbirds. Probably, if they are alive, then they represent the group of birds that are going to live on average 2 to 4 years. But most birds die. Most birds die as young of the year. That first year is really, really tough. So most species of birds, there's a lot of death in the chicks and young in the first year and first migration. And then if they make it through that, then they live somewhere 2 to 3 years for most of the songbirds. A crow is going to live, if it's a female, probably 5 to 8, and then if it's a male, maybe 6 to 9, a little bit longer. The differences in the way they invest in reproduction change their lives. Caspian tern, the oldest known Caspian tern, is 32 years old. It's not the oldest tern. The oldest tern is a common tern that was 44, and that is in a lot of ways a reflection of how long people have been doing research on them. It's easy to imagine they could be older. So there are a lot of ways. The big difference between bird species, the bigger they are generally, the longer they live. So those are some of the answers. Show us what you got, Dave.
So I did this the other day. I saw this bird and figured out what it was. And it says rare there. Can you explain why it says rare? Is that rare to Salem?
Yeah, so double-crested cormorant would be rare and uncommon right here in town. We'd expect most of them this time of year to still be on the coast or at some of the big interior lakes where they're just finishing up their breeding season and they're just starting to disperse out. And so that's one of those things. If you looked at December, then there's many more cormorants that come inland to winter. But that's primarily a big lake or big river system bird, and we're not quite at that level. The best place to see double-crested cormorants is Stotts Lake up in Kaiser, or along the river. You can see them. They kind of hang out with their wings kind of in this kind of funereal way. Or you'll see these big kind of black goose, weird-looking birds flying over really, really fast. That's another way in which they see. Where did you see it, David?
In Salem on the Willamette.
Yeah. Excellent. More questions?
This is Charlene. Back to the eBird site.
Yeah.
Are you are people concerned that there are nefarious people who put in inaccurate information?
We're not too concerned. It turns out there's not many people who appear to be nefarious. The most nefarious people would be ones who are trying to say they saw rare birds that weren't there. And so the community, the peer review community, and the culture of not lying and then needing to have evidence of what you showed is really, really high. And things that you used to be able to say you saw today oftentimes aren't accepted because people recognize we make errors and misidentifications. So unless you have a photo or a record, then sometimes you don't get to count it as an official sighting. And the ease with which the digital photography makes getting the kind of jargon as a voucher or sort of proof of it is one of the ways that it's mitigated. I mean, and there are ways. I don't know of any cases that the Lab of Ornithology has analyzed this way yet, but it's pretty easy to go and take digital photos and tell if they've been modified and go do a little analysis. So if there's something really important, then you could check it. Birding is and this, not eBird, but watching and appreciating birds is the second biggest hobby in the United States, right behind gardening. And so it's growing, and it has been growing dramatically through my lifespan. And so, and generally people aren't engaged in this, but eBird is really, really quickly growing too. So yeah.
My name is Sally.
Sally.
And we were on the osprey a few minutes ago, and I was wondering, the osprey have their nest. How do they know which one is theirs, or do they care which one is theirs after they leave and come back?
That's a great question. How do ospreys know a nest is theirs? They do know that a nest is theirs, and they'll return year after year to the same nest and defend it. The traditions of osprey are that the males and females will be longtime partners, provided breeding success is going well. And so if there's failed nests or things don't go, then they split up as a couple. Typically, the male is the one that has the key, establishes the nest site and does most of the nest building, and then that's part of his attractiveness is the place that he picked, as well as how pretty his feathers are and how big of a fish he can carry and that kind of stuff. But that his nest site selection is one of the things. So males get to those sites early. The migration timing of males and females is different. They go and they are fantastic long-term monogamous partners at the nest typically, but then they vacation separately. So the somebody's like, that's a good idea. I'm raising my hand for that. Hey, honey, what do you think about I'll go to Mexico, you go to Venezuela. I'll see you in March. Don't really know why they do that, but they do. They come back together, so they both come back to that nest site, males first, and then the pair will defend that against other osprey and eagle that try to take it. So there's lots of those who watch them closely have seen. Now, how do they know? That's a question we haven't been able to answer. Their ability to know the minds of other animals, we're getting much better at figuring out elegant, simple questions and tests to go and figure that out. We're still learning a lot about how they navigate and get from one place to another, and then how do they know a particular spot. So, an experiment that would be fun to do, that maybe it's been done, but I don't know. It's like if you took a nest pole on a particular nest and then you moved it like half of a mile, would they come back to the spot, or would they come back to the pole? Would they be looking for it? Or I would guessing they're probably like a general area and they would see it and go to it. But that would be like an experiment. Yeah.
This is Anne.
Hi, Ann.
I've
read an article about the red knot, and it
Yes.
claimed that it migrates farther than any other bird. Is that true?
Anne's talking about it's a shorebird. Let's look that up just so people can look at what this bird looks like. Another really important, interesting bird. Search red knot. It's a kind of sandpiper. Here's a red knot. So it's a kind of sandpiper, and it is a. Let's see if they've got a picture of its migration. Yeah. So here's another one of the great things about this site that you can go and get some information here in the basic profile. We could go to eBird sightings for that, but red knots are notable for they're really conspicuous on the East Coast. And they have this long distance migration from South America to North America, and they fly across this big stretch of water. They do have some of they have a stop over here, and then they breed far up here. And so they have winter here, 1 stop, 2 stops, breed. These areas are full of New York City and Boston and all kinds of people. And so there's Chesapeake Bay is a big stopping place. And so there's concern about their this particular spot that has had changes in the food resources of red knot has caused red knot populations to crash dramatically. So they have this long migration. It's not the longest migration of any bird, but it is one of the of any migration, but it is a special migration of these shorebirds. The way that it does these stops is really unique, and they are one of these birds that, having this amazing life history, the way that people have changed the habitat a little bit has mattered a lot to them, and so there's a lot of concern about them right now.
Well, I'm afraid we've run out of time,
Okay.
and so so there's more questions. But anyway, thank you so much. Fascinating.
Thank you.